Whether you're building the next unicorn startup or preparing for a system design interview, these 10 concepts are the building blocks of every scalable, reliable system on the internet. Let's walk through all of them. Scalability is where every system design conversation starts. It's the ability of a system to handle growth, more users, more data, more traffic, without breaking. You scale vertically by adding more power to a single machine, or horizontally by adding more machines. The best systems are designed for scale from day one. Load balancers sit in front of your servers and distribute incoming requests evenly across them. Think of it as a traffic cop for your infrastructure. Without load balancing, one server gets overwhelmed while others sit idle. With it, you get even distribution, fault tolerance, and the ability to add more servers seamlessly behind the scenes. Object storage is how modern systems store unstructured data at massive scale. Images, videos, backups, documents. Unlike a traditional file system, object storage is flat, infinitely scalable, and accessible via API. Think Amazon S3, Google Cloud Storage. It's the backbone of almost every media-heavy application you use daily. Message queues decouple the parts of your system that produce work from the parts that consume it. Instead of service A waiting for service B to finish, A drops a message in the queue and moves on. B picks it up when ready. This creates resilience, handles traffic spikes gracefully, and prevents cascading failures across your architecture. Microservices break a monolithic application into small, independently deployable services, each responsible for one thing. Your user service, payment service, and notification service all run separately, scale independently, and can be updated without taking the whole system down. It's how Netflix, Uber, and Amazon operate at planet scale. Caching is the performance multiplier every system needs. Instead of hitting your database every time, you store frequently accessed data in a fast in-memory layer, like Redis or Memcached. The result? Response times drop from milliseconds to microseconds, and your database load collapses. Cache wisely, and your system feels 10 times faster overnight. Databases are the heart of your data layer. Relational databases like PostgreSQL give you structure, ACID transactions, and powerful querying. NoSQL databases like MongoDB or Cassandra give you flexibility and horizontal scale. Choosing the right database for the right job is one of the most critical architectural decisions you'll make. The CAP theorem is the fundamental law of distributed systems. It states that any distributed data store can only guarantee two of the three properties simultaneously: consistency, availability, and partition tolerance. You can't have all three. Understanding this trade-off is what separates junior engineers from senior architects. Rate limiting protects your system from abuse, overload, and runaway clients. It caps how many requests a user or service can make in a given time window. Without it, a single bad actor or a bug in a client can bring your entire platform down. It's your system's immune system. Partitioning, also called sharding, splits your database horizontally across multiple nodes. Instead of one giant database struggling under load, you divide the data into partitions and distribute them. Partition 1 lives on one server, Partition 2 on another. It's how systems like Cassandra and DynamoDB handle billions of rows without breaking a sweat. CDN, Content Delivery Networks, bring your static content physically closer to your users. Instead of everyone hitting your origin server in one data center, CDN nodes around the world serve cached copies of your assets locally, lower latency, higher availability, and dramatically reduced origin load. And finally, stream processing handles data in motion, not data at rest. Instead of processing data in batches after the fact, systems like Apache Kafka and Apache Flink process events in real time as they flow through the system. It's how fraud detection, live dashboards, and real-time recommendations work at scale. Master these 10 concepts and you'll have the foundation to design any system at any scale for